Assalamualaikum and good morning. My name is Akmaluddin Azimullah bin Bashri. Matrik kad nama CN210115. We from group 5, we would like to present the project. Uh, the project title is Education Robotic Arm System. Okay, next. Okay, I will present to you the introduction for this project. Into in today's digital era, robotic plays a crucial role in inductions, particularly with the introduction of robotic arms. Developed in 1961 by Joseph Angel Birch and Josh Devol, uh, this robotic arm have evolved to meet the demands of the fourth industrial revolution, is IR 4.0. In Malaysia, the government has introduced the subject of design and technology robot, RBT means RBT reka bentuk teknologi, encompassing artificial intelligence and robotics to fourth year pupils. To address the lack of interest in robotic arm, the government has implemented a STEM strategy to enhance students' problem solving skill and digital literacy. Education robotic arms using Arduino software and coding. Arm to aim to generate student interest and understanding, serving as a foundational step toward future education, academic pursuit. The problem statement for this project is the lack of engaging the interactive robotic teaching resource in a classroom is depending students' interest and understanding of STEM subjects. Current robotic arm systems are often too complex for school students, necessitating simpler and more user friendly design to ensure effective learning. Moreover, high cost, limited accessibility, inadequate education material and curriculum standardization issue are hindering comprehensive learning experience. The declining student participation in STEM program, as highlighted by recent statistic, underscores the urgency of these issues. The allocation of significant funds for STEM and robotic education by the Education Ministry in 2023 emphasize the national importance of addressing the limitation to produce a skilled labor force capable of driving the nation's growth and economy. The aim for this project is build and program a robotic arm that serve as a educational tool for secondary school student that is related to their subject.
Hi and Assalamualaikum. I'm Muhammad Ifat bin Shariful Yamani, student Electronic Engineering Technology from UTech Pagu. So, I will present the description. The project aims to create an affordable educational robotic arm system for schools. Students will learn engineering, robotics, and automation through a user-friendly interface and a STEM-focused curriculum. So my group project focus more onto school students. University faculty will assist teachers ensuring school spirit. The system emphasizes scalability, enabling students to progress from basic concept to advanced robotic projects. It features a programmable robotic arm with sensor, an Arduino Uno brain, and educational software for programming and simulation. Users can learn programming language like Python or C++, and gain knowledge of the arm kinematic and automatic principles. As the technology advances, this system may include cloud connectivity, artificial intelligence integration, and more realistic simulation. Overall, the educational robotic arm system provide practical experience in programming, kinematic, and automation, preparing students for career in this rapidly growing field. Okay, next, objective. Okay, we have three objectives. For the first one is to design and develop a circuit design for educational robotic arm system. And the second one is to create a program for controlling circuit in educational robotic arm system. And the last one is inspire creativity and innovation in the design and use of the robotic arm system. Okay, next, for the scope, have three. So the first one is to build and design the educational robotic arm system can cater to a wide range of educational levels from primary and secondary school to vocational training center and higher education institutions. Second one is build microcontroller assembly programming. The assembly programming is for the servo motor movement and support a variety of programming language, enabling user to code in their language of choice. So the last one is consider eco-friendly design and promote sustainability in the use of disposal of robotic components. Alright, that's all for me. Thank you.
This is the layout design that we have been created through AutoCAD. This is the first draft that we made, and it may not be the same product for the final product that we have been produced. So in the initial layout design, we have been implemented the OLED to display the warning if the load become too near to the robotic arm. The ultrasonic sensor to detect the load distance, and we have set it up for 5 cm from the robotic arm. The Arduino Uno for its brain to control all the robotic arm of the servo motor and also the gripper and OLED and also the ultrasonic sensor. And for this project, we use the four servo motor to control the robotic arm. But at the end, we also added the four potentiometer to control the servo motor to move. And we use the potentiometer to be the user interface to control the degree that we want to move the robotic arm. So it has the gripper to grip the load and also to move it from point A to point B. So at the end, we also add the buzzer, the LED to turn on when the load is too near. We also have added the switch to control the whole robotic arm. When the switch is turned on, the robotic arm will be able to operate, and if it turn off, the robotic arm will not turn on.
Hello, my name is Sharmila. My metric number is C1210014. Today I will present about the list of documents that we use for software. First, we use Proteus. Proteus for connect the circuit, for create the circuit. Then next we use FreakSync. And third, we use Arduino IDE for coding. And after that we use AutoCAD to create the layout design. And lastly, we use circuit art. We extend the list of implementations of activities. First, second, LED, potentiometer, OLED, breadboard, jumper wire, switch button, ultrasonic sensor, acrylic sensors, and buzzer. I will present about the system block diagram. First, we use Arduino Uno, and we use power supply to connect with Arduino Uno. And for output, we use OLED, ultrasonic sensor, buzzer, and LED. And to control the servo motor, we use potentiometer. And for potentiometer 1 is control servo motor 1. Then potentiometer 2 will control servo motor 2. And potentiometer 3 will control servo motor 3. And lastly, potentiometer 4 we control the servo 4. Today I will present about the system flowchart. First is start. When program start, only will display the first name. And if the button we press, if yes, read potentiometer values and map to servo position. If the potentiometer 1 equal 180 degree, if yes, servo 1 will move. If the potentiometer 2 equal 180 degree, if yes, servo 2 will move. If the potentiometer 3 equal 180 degree, if yes, servo 3 will move. If the potentiometer 4 equal 180 degree, if yes, servo 4 will move. And lastly, if distance less than 5 centimeter, if yes, buzzer will on, LED will on, and will display warning lit here. Be careful. If no, buzzer will off and LED will off. That's all for
Hello, my name is Muhammad Shafi'i bin Ahmad Tai. My matrix number is CN210342. So I would like to present about a hardware picture. For the first picture, it shows that the front view of the project. The second picture is the side view of the project. And the third one is the upper view of the project. Okay, so let's move to the next slide. Okay, for the advantage and capability, the first point shows that the Arduino and potentiometer are inexpensive components, making the instructional robotic arm system affordable to educational instruction and individuals. For the second point, the Arduino is known for its user-friendly programming environment, making it accessible for beginners and students. The simplicity of the Arduino IDE allows users to quickly grasp the basics of programming. So the third one, potentiometer can be integrated with other sensors to enhance the robotic arm capabilities. So the fourth, the project integrates elements of science, technology, engineering, and mathematics, and we know as STEM, promoting interdisciplinary learning. And the student can see how concepts from different fields come together to create a functional robotic system. So the last one is building and programming robotic arm is a project-based learning experience that encourage creativity and innovation, and students are motivated to apply theoretical knowledge to real-world projects, enhancing their understanding and retention of concepts. Okay, so now I will present about safety, social, environment, and economic sustainability. For the safety, We must ensure that the robotic arm is designed with safety features to prevent accident of injuries. And we also must implement emergency stop button, limit switch, and protective enclosure. We also must choose materials that are safe for user and the environment to avoid hazardous materials and provide clear instruction on safe usage. For the social, we must design the robotic arm to be accessible to a diverse user base, including individuals with different abilities. We also must ensure that the interface is user-friendly and can be easily understood by various age groups. For the environment, we must design the robot arm to be energy efficient by using low power components and implementing power saving features. And the last one is the we economic sustainability. We must design the system in a way that allows for easy upgrade or expansion, enabling users to add new feature or capabilities without having to replace the entire system. Okay, that's all from me.
So this is the test result that we have been organized, and the first one is for us to checking the durability of the repeated movement. This is for us to show that our product is stable, and we want to make the to know the average movement, and also we want to check whether it is durable enough for us to get it as a final product. So for this test, for that all the three tests, they are slightly different time taken. And for the second test, which is it takes 2.19.65 minutes, because they are slightly movement and vibration, but it is also stable because it has a slight movement because the potentiometer may be moved a little. So the next test is for us to repeat the robotic arm to lift the same size of the load, and we have recorded the time taken for each load that we use. So the next testing result is the software testing on the degree of the servo motor part that can be turned. So there are two tests, which is the software part and the hardware part. The software is we use the Arduino, and we use the serial monitor, and as you can see, this is the final result, which is it's supposed to turn 180 degree as the coding that we have been inserted. And the hardware part is slightly different because there are some effect of the power supply or the potentiometer power that not enough gain, and it has caused there are few part which is the best can only turn to the maximum, which is 145 degree, and the gripper only can turn into 175 degree. For this discussion part, we're going to discuss about the test result that we have being obtained from the Proteus and also the Arduino IDE, of the value in the potentiometer and the degree of the servo motor operation. This is based on the in the serial monitor, and also the degree that we have been measured for the robotic arm to turn it on servo motor. Based on the simulation that has been done, the potentiometer is in full operation, um, and the degree of the servo motor is moving from 0 to 180 degree. It is also being able to display the warning of the load of being too near from the robotic arm. When the load is being too near, the LED will turn on, and also the buzzer will turn on also to indicate the load is being too near to the robotic arm. Okay, the next test is for the difference of the load lifted by the robotic arm. This is we can see because we changed the size of the robotic arm, and the time taken for it is also different. This will decide to use the same specification to be lifted to see the difference in the time of the lifting from one point to another point. It will be sometime be affected by the few aspects such as experience of the handler. Um, this is due to my own experience. When the when the user is new, there are often the time for they to lift the load from point A to point B will be more longer because they are not usual for this interface by using the potentiometer. Okay, next is the term of discussion of the durability. It is to test how the robotic arm will perform if the robotic arm will operate on the same basis and repeatedly. The researcher take the test to be only taken 3 times because it is a usual amount to be taken for testing the average of the performance. But at the end, the researcher found out that one section has a slight vibration from the robotic arm, but it is still maintained stable and the load will does not fall down from the gripper. This is due to the coding that have been implemented. Uh, the researcher have using the coding to strengthen the gripper strength. For the future improvement from our robotic arm, there are few future improvement that we have been thinking of, which is the first one is the enhanced dexterity and precision by developing the robotic arm that will increase the dexterity to handle delicate tasks with precision, such as in surgeries or manufacturing processes. For our robotic arm, it will be able to only lift the load, and uh, our future improvement is we want the robot to be able to perform the tasks that we human be able, such as for surgeries. And for our field, our main objective is only to lift the load. So if there any improvement, then we should be able to perform the task with precision. The next one is the enhanced collaboration tool. It is to developing better platform for collaborative coding, enabling real-time collaboration, code review, and pair programming to improve productivity and code quality. For this project, our coding is only consists of the servo motor to be controlled by the potentiometer, but for the future improvement, the other researcher may want to add the auto controlling for this robotic arm. They want to create another app such as MIT App Inventor to be used to control the robotic to be more delicate, and also they want to use the another platform such other than Arduino IDE that we have been using. The next one is the modular design for flexibility. For designing 4 degree of freedom system with modular component to allow for easier customization and reconfiguration, making them more adaptable to different tasks and environment. We using the 4 degree of freedom because it is more easier. But for the future researcher, they maybe want to increase the degree of freedom, such as 5 degree of freedom or 6 degree of freedom, and it will be more precise and will be more easy to reconfiguration because it will be more adaptable to the task or the environment that they want. As for us, we want the task is to show the kids in the education field how the robotic arm will be performed by using the software such as Arduino, the circuit as such as Proteus, and also the hardware such as using the Arduino Uno and also the OLED. So that is all for the future improvement of our robot. Okay, for the conclusion, at the end, the objective that we aim for at the beginning of the project is being able to achieve due to the able to design the circuit design of the educational robotic arm design. This is being solved by using Proteus to simulate the software, and also we use the freezing and circuit I/O to get an early imagination to our final product of the circuit that we want to design. Next objective to be achieved is to create the program to control the circuit, and the outcome is to able control by using potentiometer using Arduino IDE. By using the coding, we be able to control the movement of the servo motor by only using potentiometer, and it will be able to lift the load by only using the potentiometer, and also other components such as OLED, ultrasonic sensor, and also LED. In summary, the robotic arm that was being able to control manually by using potentiometer is successful and achieve what the researcher want. The robotic arm being able to display the warning if the load it want to leave become close and the buzzer become responsible to give warning to this operation. The potentiometer that control the servo motor being able to give the output with a slight delay and able to lift the gripper. A gripper has been equipped with the gripper strength and the vibration being able to be slowed down. This is being able to slow down by making the potentiometer to become more stable by using the user interface, and we create a box to make it to lower the vibration and make it more stable. So, by meaning of the slight delay is sometimes the potentiometer will have some time to turn it servo motor degree to what we want. So that's all for the conclusion. This is all the reference that we choose from the early of our project until the end of our project, such as our previous study that we have been referred to, and also the news that we have been used to create the problem statement, and this is all the reference that we have been using, such as news and also the journal that have been created by other researcher, previous researcher that we've been able to find on online.